American river engineers between 1820 and 1900 diverted, channelized, or significantly modified the alignment of approximately 20 major American rivers. They used methods that are essentially extinct today: wing dams, timber cribs, brush mattresses, spur dikes, bend cutoffs. The Civil War-era U.S. Army Corps of Engineers under General Andrew A. Humphreys formalized many of these methods in the 1870 reports. James Buchanan Eads designed jetties at St. Louis in 1875 that scoured an additional 24 feet of low-water channel depth into the Mississippi River. Many of the original structures from the 1820s through the 1900s are still on the river bottoms doing their job today. The forgotten engineering trick is hydraulic scour. The basic principle is simple but counterintuitive. If you want to deepen a river channel, you do not necessarily need to dredge the river bottom with mechanical equipment. Instead, you can design structures that constrict the river flow to a narrower channel, which increases the water velocity in that channel, which scours sediment out of the channel bottom and carries it downstream. The river itself does the dredging work. The engineer only needs to design and build the constriction structures that channel the flow. American river engineers between 1820 and 1900 mastered this technique to a degree that has not been matched in modern American river engineering. They diverted 20 major rivers and modified hundreds of smaller streams using hydraulic scour principles, with structures built primarily of stone-filled timber cribs and brush mattresses anchored to the riverbed. The technique requires a deep understanding of river hydraulics that the 19th century engineers developed through observation and trial and error, rather than through formal mathematical analysis. Modern river engineering uses computational fluid dynamics, sediment transport equations, and finite element analysis to predict how water will flow around a structure. The 19th century engineers had none of those tools. They had Newton's basic mechanics, some empirical hydraulic formulas developed by European engineers, and direct observation of how rivers behaved under various flow conditions. They built test structures, observed the results, modified the designs based on what they saw, and gradually accumulated a body of practical knowledge about hydraulic scour that allowed them to predict with reasonable accuracy how a proposed structure would affect a particular river. The wing dam was the most common American river engineering structure of the era. A wing dam is a long line of stone-filled timber cribs extending from the riverbank out toward the main channel, angled either upstream or downstream depending on the desired effect. A wing dam pointed upstream and angled outward into the channel forces the river flow to bend around the dam, which increases the velocity of the flow in the main channel and scours sediment from the channel bottom. A wing dam pointed downstream creates a slack water zone behind it where sediment can settle out of the flow, gradually building up new land at the bank. American river engineers used both types of wing dams in various combinations across the 1820s through the 1900s to engineer the flow patterns of major American rivers. If you appreciate of these American industrial heritage stories and want to support more of them, join at the Boss tier for early access and members-only polls, or Final Boss for member shoutouts and members-only videos. The link is in the description below. Now we walk through the specific engineers who developed the American river engineering tradition. The technical theory behind hydraulic scour engineering was developed gradually through the 19th century by a combination of European theoretical work and American practical experience. The basic theoretical foundation came from the work of Antoine de Chézy in 18th century France, who developed the first mathematical formula for predicting water velocity in open channels based on the channel slope, the hydraulic radius, and an empirical roughness coefficient. The Chézy formula was further refined by the Irish-Scottish engineer Robert Manning in 1889, producing the Manning formula that remains the standard hydraulic engineering equation today. The American river engineers of the 19th century used the Chézy formula and various empirical refinements developed through Corps of Engineers field experience to calculate the expected scour effects of proposed wing dam structures. The sediment transport theory that explained why scoured river channels deepen over time was less well developed during the 19th century. Modern sediment transport science was not formalized until the work of Hans Albert Einstein, son of physicist Albert Einstein, in the 1940s. The 19th century American river engineers had only empirical observations of sediment behavior, accumulated through decades of field experience with various river engineering projects. They knew from observation that accelerated water flow would scour sediment from a channel bottom. They knew that the scoured sediment would deposit downstream where the flow slowed. They knew that the long-term equilibrium depth of a scoured channel depended on the local sediment supply, the flow regime, and the constriction geometry. They did not have mathematical models of these processes, but they had reliable rules of thumb developed through trial and error. The Mississippi River Commission, established by the United States Congress in 1879, became the primary American institution for river engineering research and field practice through the late 19th century. The commission was created in response to repeated flooding on the Mississippi River and was tasked with developing systematic engineering approaches to flood control, navigation improvement, and river channel maintenance. The commission was chaired by General Quincy Adams Gilmore of the Corps of Engineers, with civilian engineers including James Buchanan Eads serving as end commissioners. The Mississippi River Commission produced detailed annual reports throughout the 1880s and 1890s, documenting the engineering work along the Mississippi River. The annual reports became the standard reference for American river engineering practice for the next several decades. James Buchanan Eads was the most famous American river engineer of the 19th century, though his fame today rests primarily on his Eads Bridge across the Mississippi River at St. Louis, completed in 1874. Eads was also the major designer of the Mississippi River jetties at the river's mouth, completed in 1879. The Mississippi River jetties were a hydraulic scour project on a massive scale. Before the jetties, the Mississippi River entered the Gulf of Mexico through a delta with multiple small distributary channels, none of which had enough depth to allow ocean-going ships to enter or leave the river. The river's low water depth at the mouth was approximately 10 feet, far too shallow for the ships of the era. The Port of New Orleans was effectively cut off from international shipping during low water periods. Eads proposed to solve this problem by building jetties at the river's mouth that would constrict the flow into a single channel and use hydraulic scour to deepen that channel. The jetties were built between 1875 and 1879. They consisted of long lines of stone-filled timber cribs and brush mattresses extending from the river banks at the mouth out into the Gulf, forcing the river flow into a single channel approximately 1,000 feet wide. The hydraulic scour effect was dramatic. Within 3 years of jetty completion, the channel depth at the river mouth had increased from approximately 10 feet to over 30 feet. The Port of New Orleans became fully accessible to international shipping. Eads received a fixed-price contract of $5 million for the jetty work, with a contractual guarantee that he would receive payment only if the channel reached a specified depth. He delivered. The jetties paid for themselves within a decade through the increased commerce flowing through the Port of New Orleans. I have written the full story of this down. The Erie Canal, Volume 1, The Men Nobody Wrote a Book About. Every worker in it came from the real payroll records. If you want it, the link is in the description, or scan the code on screen. Now, back to the work. General Andrew A. Humphreys was the head of the United States Army Corps of Engineers from 1866 to 1879. Humphreys had served as a Union Army general during the Civil War, commanding infantry units at Gettysburg and elsewhere. He had a background in engineering from his pre-war Corps of Engineers service. As head of the Corps of Engineers after the war, Humphreys directed a comprehensive technical study of American river engineering practices and produced a series of reports in the late 1860s and 1870s that formalized the American river engineering tradition. The Humphreys reports compiled the accumulated practical knowledge of wing dam construction, brush mattress design, bend cutoff engineering, and revetment work into systematic engineering specifications that subsequent Corps engineers could follow. If you are new here and enjoying this kind of historical depth, subscribe so you do not miss the next video. We publish 2 videos per day this week. Now we walk through specific examples of American river diversion projects. The Eads Mississippi River jetties construction work between 1875 and 1879 deserves more detailed treatment because it was the largest single hydraulic scour project in 19th century American river engineering. The jetties were located at the South Pass entrance to the Mississippi River, one of the 3 main distributary channels at the river mouth. Eads selects South Pass over the other channels because it had the deepest natural channel depth and offered the best potential for hydraulic scour improvement. The jetties consisted of 2 parallel lines of stone-filled timber cribs, each approximately 2 miles long, extending from the riverbank at the South Pass entrance straight out into the Gulf of Mexico. The total stone fill in the jetties was approximately 1 million tons, primarily limestone quarried from upriver quarries and shipped to the construction site by river barge. The construction work was personally managed by Eads from a houseboat moored at the South Pass entrance. Eads spent essentially the entire 4 years of construction living on the houseboat with his engineering staff, supervising the day-to-day work and adjusting the jetty designs based on observed scour results. The workforce was approximately 1,200 laborers at peak, primarily African-American workers from the New Orleans labor pool, plus some Irish immigrant workers. The work was extraordinarily dangerous because of the offshore location, the weather exposure, and the heavy stone handling required for the crib construction. Approximately 40 workers died during the construction over the 4-year period, primarily from drowning, crushing accidents from falling stones, and weather exposure during winter storms. The financial structure of the Eads jetty contract was unique in American civil engineering history. Eads accepted a fixed-price contract of $5 million for the work, with payment conditional on achieving specified channel depths. The contract was structured as a series of payment milestones tied to channel depth measurements taken by independent federal engineers. Eads received no payment until the channel reached 18 feet of depth at the South Pass entrance, received the full contract amount only after the channel reached 30 feet. The federal engineers measured the channel depth quarterly throughout the construction and operating period, with the payments released as the depth milestones were achieved. Eads met all of the depth milestones on schedule, with the channel reaching 30 feet of depth approximately 2 years after jetty completion. The total payment to Eads ultimately exceeded $6 million, including some additional work beyond the original contract scope. The Wisconsin River Wing Dam system is one of the best preserved examples of 19th century American river engineering. The Wisconsin River runs approximately 430 miles from northern Wisconsin south to its confluence with the Mississippi River near Prairie du Chien, Wisconsin. Beginning in the 1860s and continuing through the 1890s, the U.S. Army Corps of Engineers built approximately 300 wing dams along the lower Wisconsin River between Stevens Point and the Mississippi confluence. The wing dams were designed to maintain a navigable channel of at least 4 feet depth for steamboat traffic between Stevens Point and the Mississippi. The wing dams worked. The Wisconsin River carried regular steamboat commerce between the 1870s and the early 1900s. After the railroad expansion displaced steamboat commerce, the wing dams continued to maintain the river channel for recreational and ecological purposes. Approximately 200 of the original wing dams remain in place today, still functioning as the river engineering structures they were designed to be. The Ohio River Wing Dam system extended along most of the Ohio River main stem from Pittsburgh, Pennsylvania to Cairo, Illinois. The Corps of Engineers built more than 1,000 wing dams along the Ohio River between approximately 1840 and 1930. The Ohio River Wing Dams maintained a navigable channel for steamboat traffic and later for the lock and dam system that the Corps of Engineers built in the early 20th century. The original 19th century wing dams were gradually replaced or absorbed into the modern lock and dam infrastructure during the 1920s through the 1950s. Some original wing dams from the 1860s and 1870s are still visible at low water levels in various Ohio River reaches. The Sacramento River in California saw extensive wing dam construction during the Gold Rush era and the agricultural expansion of the Central Valley. The Sacramento River wing dams were designed primarily to maintain navigable depth for steamboat commerce between the Port of Sacramento and the Sacramento Delta. Approximately 70 major wing dams were built along the Sacramento River between 1855 and 1895. Most have been removed or buried under modern construction, but a few original wing dams from the 1870s remain visible in the Sacramento Delta at low water levels. The bend cutoff method was a different kind of 19th century river engineering technique. A bend cutoff is a canal-like channel cut across the narrow neck of a river oxbow bend, allowing the river to flow through the cutoff rather than around the bend. The bend cutoff shortens the river mileage and steepens the gradient through the cutoff section, which both speeds up the flow and reduces flood elevation upstream of the cutoff. American river engineers used bend cutoffs extensively on the Mississippi River, the Ohio River, the Wabash River, the Cumberland River, and various other major rivers between approximately 1840 and 1880. The cumulative bend cutoff work eliminated approximately 600 river miles from American navigable rivers, primarily on the Mississippi River system. The Missouri River bend cutoff and channel work was another major American river engineering tradition that developed somewhat separately from the Mississippi system work. The Missouri River runs approximately 2,340 miles from its source in Montana to its confluence with the Mississippi near St. Louis. The Missouri is notable for its extraordinarily high sediment load, carrying approximately 175 million tons of sediment per year through the natural watershed. The high sediment load creates particularly challenging engineering conditions, with channel bottoms shifting rapidly, banks eroding aggressively, and bend cutoffs occurring naturally as the river meander system evolves. The Corps of Engineers built approximately 800 wing dams along the Missouri River between 1860 and 1930, primarily concentrated in the lower 300 miles between Sioux City, Iowa, and the Mississippi confluence. The Missouri wing dams have been largely replaced by the modern lock and dam system built between 1930 and 1960, but some original wing dams remain visible at low water levels. The Tennessee River Wing Dam system extended along most of the Tennessee River main stem from Knoxville, Tennessee to the Ohio River confluence at Paducah, Kentucky. The Corps of Engineers built approximately 300 wing dams along the Tennessee River between 1875 and 1920, primarily to maintain a navigable channel for steamboat traffic. The Tennessee River wing dams were largely replaced by the Tennessee Valley Authority Dam system, built between 1933 and 1949. The TVA dams created a series of large reservoirs along the Tennessee River main stem, submerging most of the original wing dam infrastructure. Some original Tennessee River wing dams remain visible during periods of TVA reservoir drawdown, but most are now permanently underwater. The most famous single bend cutoff in American river engineering history was the Yazoo Cutoff on the Mississippi River, completed in 1845. The Mississippi River north of Vicksburg, Mississippi had developed a particularly tight oxbow bend that added approximately 12 river miles to the route between Memphis and Vicksburg. The U.S. Army Corps of Engineers cut a channel approximately 1.5 miles long across the narrow neck of the oxbow, allowing the river to flow through the cutoff. The cutoff worked. The Mississippi River shifted into the cutoff channel within several months of completion. The original 12-mile oxbow became a dead-end backwater attached to the river at only one end. The total river mileage between Memphis and Vicksburg dropped by 10.5 miles. The Yazoo Cutoff also incidentally moved the boundary between Mississippi and Arkansas, since the state boundary at that point had been defined as the center line of the river, and the river had shifted location. Some land that had been in Arkansas before the cutoff was now on the Mississippi side of the river, and vice versa. The boundary disputes from the Yazoo Cutoff took decades to resolve through court action. The Sacramento River Wing Dam construction during the California Gold Rush deserves more detailed treatment because it was the most extensive Western American river engineering project of the 19th century. The Sacramento River had become the primary commercial transportation route between San Francisco Bay and the gold mining regions of the Sierra Nevada foothills after the 1849 Gold Rush. The river carried passenger and freight steamboat traffic between San Francisco and Sacramento, with smaller boats continuing upstream to Marysville on the Yuba River and to other gold mining centers in the foothills. The river channel maintenance was critical to the gold rush economy, and the Sacramento Bee and other regional newspapers covered the river engineering work extensively throughout the 1850s and 1860s. The Sacramento River sediment load from the gold mining operations was extraordinary. The hydraulic mining operations in the Sierra Nevada foothills washed approximately 1.5 billion cubic yards of sediment into the Sacramento River drainage between 1853 and 1884, when hydraulic mining was finally banned by federal court order. The cumulative sediment load completely altered the Sacramento River channel system, raising the river bottom in some sections by 10 to 20 feet, eliminating navigable depth in numerous reaches, and creating extensive new bottomland deposits that became the basis of the modern Sacramento Delta agricultural region. The American Rivers engineers working the Sacramento system during this period faced engineering challenges far beyond the typical wing dam and brush mattress work used on the eastern rivers. The Sacramento engineers had to design structures that could handle massive sediment transport, repeated channel reshuffling, and the political fight over hydraulic mining that ultimately resulted in the 1884 federal court ruling banning the practice. The brush mattress was the other major American river engineering structure of the 19th century. A brush mattress is a woven mat of willow brush, typically 30 to 60 feet square, that is sunk to the riverbed and anchored in place with stone weights. The brush mattress lies on the river bottom and protects the bottom from erosion, while allowing water and fine sediment to flow over and around the brush. brush mattresses were used extensively to protect riverbanks from erosion, particularly in revetment work, where the river was eroding into the bank and threatening adjacent land or infrastructure. The Corps of Engineers built tens of thousands of brush mattresses along American rivers between approximately 1850 and 1940. The brush mattresses gradually degraded as the willow brush rotted in place, but they continued to provide bank protection for 15 to 30 years per installation. After the brush mattresses degraded, the stone weights remained on the riverbed and continued to provide some bank protection by their mass alone. The technical lineage from 19th century American river engineering to modern American river engineering is more complicated than the canal or bridge engineering lineages. Modern American river engineering uses primarily reinforced concrete, steel sheet piling, and machine-built earthworks. The brush mattress, the timber crib wing dam, and the hand-built bend cutoff are essentially extinct as working construction techniques. The Corps of Engineers stopped specifying brush mattresses in the 1940s. Timber crib construction was largely replaced by concrete and steel construction by the 1960s. Bend cutoff work continues but is now done with mechanical excavation rather than hand labor. The 19th century construction methods are preserved primarily in the historical structures themselves, which continue to function as river engineering even as the methods used to build them have disappeared from active practice. Anyone who has seen the masonry on a 150-year-old wing dam knows this. The 19th century American river engineering tradition was a particular form of engineering courage. The engineers were modifying systems they did not fully understand mathematically. They were betting that their observations of river behavior were accurate enough to predict how a proposed structure would actually affect the river. They were spending public money and risking public infrastructure on those bets. The Mississippi River jetties cost $5 million in 1870s dollars and were guaranteed by Eads only if they delivered the specified channel depth. The Wisconsin River wing dams cost the Wisconsin congressional delegation extensive political effort to fund through the Corps of Engineers appropriations. The bend cutoffs cost the affected state governments substantial budget commitments. The work was speculative engineering in the modern sense. It worked because the engineers were careful, observant, and willing to learn from each project. The reason many of the 19th century structures are outlasting their 20th century replacements is a quirk of materials science. Timber crib structures, when fully submerged in fresh water, decay very slowly because the lack of oxygen in submerged conditions prevents the bacterial and fungal action that breaks down wood in surface environments. A timber crib submerged in a river for 100 years may show very little structural decay if the wood remained continuously submerged. The wood becomes saturated with water, which prevents oxygen penetration into the wood fibers, which prevents the rot organisms from being active. Many of the original 1850s through 1880s American river engineering timber cribs are still in essentially original structural condition because they have been continuously submerged for over 100 years. Modern reinforced concrete structures, by contrast, have a known service life of approximately 50 to 100 years, after which the steel reinforcement begins to corrode and the concrete spalls. The timber cribs may outlast the concrete that was designed to replace them. If this is the kind of history you want kept, the book is the place it lives. The Erie Canal, Volume 1. Link in the description, or scan the code. Thank you for sitting with these men. Before we close, if this kind of pre-modern engineering story is what you came for, the final boss tier at $9.99 gets you members-only videos plus your name in upcoming uploads. Boss tier at $4.99 for early access. Link in the description. Thanks for watching to the end. Many of the wing dams, timber cribs, and brush mattresses built between 1820 and 1900 remain on the river bottoms of the Mississippi, the Ohio, the Wisconsin, the Missouri, the Tennessee, and the Sacramento rivers today. The methods were displaced by reinforced concrete and steel sheet piling after 1900. Some of the concrete replacements built after 1950 are now failing first. The original timber crib structures, hand-built by Civil War-era American river engineers, are outlasting the concrete designed to replace them. James Buchanan Eads died in 1887. His St. Louis, Mississippi River jetties are still scouring the river channel today. General Andrew Humphreys died in 1883. The Corps of Engineers tradition he established continues to manage American river infrastructure under the same engineering principles he formalized in the 1870 reports. The Wisconsin River Wing Dam system is still functioning. The Ohio River Wing Dam fragments are still on the river bottoms. The Sacramento River wing dams are still partially in place at low water. The forgotten engineering trick was hydraulic scour. The river does the dredging work. The engineer designs the constriction. The structures stay in place for over a century. The records prove it. The rivers continue to flow through the channels the 19th century engineers designed for them.